Hi everyone and welcome to our channel. Today will be the start of the sensor series, beginning with the light sensor. We'll go over some important information about the light sensor as well as how to build and code the sensor into your prototype. The light sensor, also known as a photocell, changes resistance depending on the amount of light exposed. We can determine how much light is hitting the surface of the sensor by measuring the resistance. Meaning the more light detected, the lower the resistance, or the less light detected, the higher the resistance. These sensors are great for ambient light triggers like night lights. We're now going to jump into how to build your light sensor. For this activity, you'll need a Redboard, a breadboard, a light sensor, a 10K ohm resistor, 1 LED, and 6 male-to-male jumper cables. Be sure to follow the diagram and keep in mind where the LED, the light sensor, and the resistor are located on your breadboard. Make sure you place the LED and photoresistor on opposite sides of the breadboard so that the light from the LED does not fall too brightly on your light sensor. After completing your build, now launch your Arduino IDE and add the following code into your sketch. The code roughly means the constant integer being declared will have a constant value and won't change. For example, the light pin is always set to analog 0, and the LED pin will always be set to pin 3. Also note that spelling and capitalization are important when declaring a name to a specific pin number. Inside the curly brackets of the void setup, the serial begin will send data to the serial monitor at 9600 bits per second. We'll talk more about the serial monitor and its usefulness later on in this video. The pin mode establishes the LED as an output. Inside the void loop, the integer light voltage, analog read, and serial print line all create a variable to store light voltage values. This if-else statement implies that if the condition is true, then execute the following statement, meaning if the light voltage is less than 650, turn the LED on. Or else, when the voltage is greater than 650, the LED should be turned off. The delay will pause for 200 milliseconds before looping again. After completing your code, make sure the Redboard is connected to your computer using a USB connection. Also ensure your port is selected to the COM with the highest number. Once connected, you're ready to upload your code. Make sure you double check for spelling and punctuation before clicking upload. Referring back to our code, our light sensor is programmed to detect a voltage value of 650. Keep in mind, voltage values can range between 0 and 1023, but to monitor the values collected by your sensor, you'll need to utilize your serial monitor. In the Arduino IDE, select the magnifying glass icon at the top right of the window. This window will display values once you've uploaded your code to the Redboard. The voltage reading from the photocell provides a value between 0 and 1023. With a 0 value meaning the sensor is at 0 volts and a 1023 value meaning that the sensor is at 5 volts. Keep in mind, higher voltage numbers indicate lower resistance and vice versa. Place your hand slightly over the sensor to limit the amount of light touching the photocell. This should decrease the numbers being displayed on your serial monitor, indicating resistance is increasing. The value that will switch the LED on is any number below 650. Now fully cover the photocell to increase its resistance to turn the LED completely on. Thanks for watching, and please let us know if you have any questions in the comment section below, and be sure to check out our other videos on our First Nations Mesa channel.